Morning everyone. Uh, I would like to present my project on Bio-Adhesive made up of natural materials. So before I start my project, I want to introduce myself. I am Professor Arun Gupta and working in University Malaysia Pahang in Faculty of Chemical and Process Engineering. My teammate in this project is Triveni Soubam. She is a PhD student and we together have developed this Bio-Adhesive. So before we start on this product, first of all, I would like to tell more about it. That Malaysia is one of the top 5 exporter of wood and wood-based composite, and it is exporting to the US, Japan, Europe, and a lot of wood composite every month are going outside. All these wood composite industries are using the standard adhesive, urea formaldehyde and phenol formaldehyde, and in both these commercially available adhesive, formaldehyde is one of the main part. Okay, because of having the formaldehyde, then the adhesive always emit a small volume of formaldehyde, and the International Agency for Cancer Research have done a lot of work on it, and they have found that the excess exposure to the formaldehyde emission can cause cancer. So when I joined here in 2009, and I have met some of the main manufacturer of wood composite, and they have said that it is really a big problem because of this they cannot export to the developed countries, and all the developed countries are putting ban on the import of wood-based composite having a high level of formaldehyde. From there, 2010 onwards, we start working on developing alternative adhesive without formaldehyde. So we have started with lignin and then the soya, and now the best product we got is from the natural rubber latex, rice starch, and the cross-linker. Okay, so this bio-adhesive will be used for plywood, medium density fiber board, particle board, and for the any other wood composite, wood-based composite. So these are the main one, and everyone knows about it. And Malaysia is having some of the biggest MDF and particle board plants. There are more than 12 MDF plant and a lot of particle board and several hundred plywood units. More than 100 K people are working, and wood-based industries are playing an important role in the economy. Okay, so for the application part, all these wood-based composite are used in the furniture. So we can say sofa, cabinet, book shelf, inside the building, flooring, and the outside the building also. There's a huge application of wood and wood-based composite. And if we are using the wood composite, which is having a formaldehyde-based adhesive, then it will continuously emit emissions, and that the excess exposure can cause the cancer. So it is a real problem for everyone. Okay, a little bit about the Malaysian wood-based industry. So most of these industries are based in Sabah 12%, Sarawak 21%, Peninsular Malaysia 67%, and the Malaysian timber industry is contributing 17.9 billion through the export in 2021. So as you can see from here, from this figure 17.9 billion, that wood-based industry is playing an important role in the economy of the Malaysian economy. Okay, so at present all these medium density fiber board, particle board, and plywood, they are using these two common commercially available adhesive, phenol formaldehyde and urea formaldehyde. And as you can see, both are formaldehyde based, and they can emit the formaldehyde vapors, and that can cause cancer. It is already a lot of research done in the developed countries, and they have found a link between the formaldehyde emission and the cancer. Urea formaldehyde is available in both the forms, in the liquid form and also in the powder form. So as you can see that whenever we are in our house or in the office, we are surrounded by the wood-based furniture, and if they are using the adhesive formaldehyde base, then we are always exposed to the to this formaldehyde emission. Okay, so whenever we are inhaling formaldehyde vapors, then people will feel the headache, the pain behind the eyes, cough, runny nose, and the excess exposure can also cause the cancer. Okay, so there are different ways in which the wood-based industries are working to lower or to reduce this problem. So one is in the existing urea formaldehyde and phenol formaldehyde, they are playing around with the molar ratios and then trying to reduce. And another way is to develop the bio-adhesive or adhesive which is based on the materials like the soya, starch, natural rubber latex. There are a few researchers and companies who have developed, but one of the main problem is whenever these bioadhesive we use in the wood composite, so they absorb a lot of water. So when they absorb water, they will become thick and all the fibers will come out. So we have developed it. We have introduced the cross linker which can attach the natural rubber latex and the rice starch, and we have conducted the test and we have found that all our products are passing the market standard. Later on I will show you in the slides that we have conducted all the standard tests and we are passing the market standards. Okay, so these are some of the pictures showing the natural rubber latex and the rice starch plus the cross linkers. Okay, in these slides we are showing only some of our results, but we have published papers in number of journals, so all the details or the scientific results are there. Here I am just showing some of the main combinations we have done. We have formed suppose 3 formulation with the natural rubber latex and rice starch with 5 and 15 and 10, 10 and 15 by 5. So this because we want to know that how much is the optimum range of this combination that can give the best results. So from all our combinations, the 50% natural rubber latex and 50% rice starch with a cross linker of 0.3 to 0.5 have given us the best results. So now, because when we have developed the bioadhesive, we also need to test all the samples that we have produced. So like one of the main important testing is internal bonding. Internal bonding will test, like suppose we have made the wood composite samples, and then we will test in the universal testing machine that we will put the force on both the end and we will see that how much it can take. So that is called internal bonding test, and that is one of the main tests to know the strength of the bioadhesive. So we have conducted the test for all our combinations, and actually all our combinations have passed the market standards, and the best result is coming out from the when we have the mixture of 50% rice starch and 50% natural rubber latex. So the internal bonding strength is 2.2 megapascal. Another important property for any wood composite is the modulus of rupture and modulus of elasticity. Basically, it means that we are having the board and we want to test that how much load the wood composite can take, because we are going to use it in a bookshelf or in the cabinet or in the table, so we need to know that okay, how much load it can take. Otherwise, if we don't test it and we put too much load, then the whole board will be broken. So we have conducted the modulus of rupture test using the universal wood testing machines, and from the result you can see that all our combination have passed the market standard, and the best result is given by the 50% combination. We have also conducted the modulus of elasticity, which is also same like MOR. So these are the common tests for any wood composite to go in the market. So whenever some company want to sell some composite, then they need to provide all the details, and there are certain standards that it need to pass. We have also conducted water absorption. We have put the samples into the water for 24 hours and we have seen that how much water it is absorbing. So the amount of water it is absorbing is very less, which is passing the market standards. Okay, now it is because whenever we develop the new product, it is not only that it can replace the urea formaldehyde or phenol one, we also need to test that it is market acceptable. We have done the calculations, and because natural rubber latex in Malaysia, after the palm plantation, the second highest plantation is of rubber trees. So natural rubber latex is comparatively cheaper. We can easily find it, and then we have done the calculation. So the bioadhesive will be more than 10% cheaper than the existing urea formaldehyde and phenol formaldehyde. So all the industries can accept this new product, and it is also commercially viable. Okay, we are from 2010 onwards. We are working with a lot of big wood composite industry like the Mikochi board, Robin Resources, Segamat board. We have also signed the MOU with them, and we are regularly, not only we are doing the testing in our lab, but we are also conducting the trial test in the plant. We have done the testing in the Mikochi board, which is in Gebeng. It is one of the biggest chipboard company of Malaysia. We have done the trial, and then whatever, suppose we are doing this development from 2010 onwards, and whatever shortcoming are there, we are coming back and developing into our lab, and again going back. So we are having the collaboration with some of the big companies, and in the near future, these are the companies which are going to commercialize. They are going to bring a special kind of the wood composite. It will be under the brand of the green technology, and it will come in the market very soon. So here in the picture you can see that the head of the Mikochi board, and that time our Vice Chancellor, Deputy Vice Chancellor have signed the MOU with the Mikochi board. Next picture is the Robin Resources. It is one of the biggest MDF manufacturing company in Malaysia. It is in the Limardo, and we have also signed MOU with them. And these are the companies which will bring our bioadhesive into the market. We have also published our work in different through different research papers, and you can see here at the Australian Journal we have published one research paper. Then we have also published the review paper in the another journal, and we have also in 2014 we have published another paper in the Indian Academy of Wood Science. So all the detailed results are there, that all the FTIR, DGA, and the detailed descriptions we have given in these papers. We have also filed one patent on our new combination of the natural latex, rice starch, and the cross-linker. And previous year we have received gold medal in Citrax for our new product. So judges were satisfied with the work that we are doing, and they have found that this work can be commercialized and is having a wider impact. So at the end, I would like to conclude that the product that we have developed is very good, eco-friendly. It is 100% free from formaldehyde, because we are not using any formaldehyde into it. Our product have passed all the market standards, so it can be easily adapted, and it is also comparatively cheap. So all in all, it is a nice discovery or the product that can be easily can be commercialized not only in Malaysia but worldwide. So I think with that, that's all from my side. Thank you very much for your time.